Hello everyone. Welcome to another Astronomy Trivia Night. I'm your host, Dr. Ilana McDonald of the David A. Dunlap Institute, Department for Astronomy and Astrophysics, and I'll be your host this evening, asking you amazing astronomy questions to win fabulous prizes. So for those of you who are joining right now, please go to kahoot.it and enter the game pin that you see on the top of the screen. So enter 1304852 into kahoot.it, or if you have the Kahoot app, you can do that too, and enter that number and you can join in on the fun and games. And just want to say that as you're putting your fun names in, please use your real email address if you hope to win prizes tonight, because we cannot contact you if we don't have your actual email address. So when you sign up for Kahoot or you sign into Kahoot, please use your real email address. And we 100% promise that we will not contact you for any reason except for if you've won a fabulous prize. And I'm very excited about the prizes tonight. They're all very, very, very cool. So I'll just give it a few moments for a few more of you to join in. We've got some fun names popping up on the screen right now. Very excited to play with you all tonight. If you want to, while you're waiting, you can say in the chat where you're playing from tonight. That's kind of fun. Introduce yourself, tell us what you love about astronomy. And for those of you who are just joining right now, please go to kahoot.it if you want to join in on the games and put in the game pin that you see at the top of the screen. We'll have it in the chat in just a moment. There it is, right in the chat. And and put your real email address in if you hope to win a prize. So we'll just give it another minute or two, and then we'll get started. Looks like we've got some people from all around. Wow, we have someone from Colombia, someone from Nova Scotia, someone from Newmarket, someone from Alberta. That's really cool. Welcome everyone who's playing today. That's very, very exciting to see you all here. I'm just going to give it maybe one more minute and we'll get started on the games. And once again, if you're just joining now, please do go to kahoot.it so you can play along, and you can put the game pin 1304852 in the place where you put it in the game, in the app, and please put your real email address in if you hope to win a prize. All right. It's nice to see some people from all over Ontario, from all over the world. So great to see you all here tonight. All right, we've still got people signing in, so I'm just going to give it maybe another 30 seconds. We've got someone from Quebec. That's exciting. All right, it looks like the sign-ins have slowed down a bit, so we're going to start playing the games tonight. Although, before we start, I want to do a quick land acknowledgement. We wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. Today, this meeting place is still the home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So, let's get started with our fun little trivia night run by Kahoot, of course. And our topic for the evening is galaxies, which is a pretty cool topic. Before we get started, we have a few rules to go over. Anyone, of course, can play, but we can only, unfortunately, send prizes to Canadian addresses outside of Quebec. So I'm sorry for those of you outside of Canada and in Quebec, but you are welcome to play along anyway and see how many of the answers you get. Also, people with graduate degrees in astronomy are not eligible to win prizes. We just think that, it would be a little bit unfair if you already have a PhD in astronomy to play along. If you are under the age of 18, just make sure that you have your parents' permission to play. Totally cool for you to play. We just got to make sure that it's all good to go. And in that vein, since there might be people who are under the age of 18, please keep the chat respectful and family friendly. And as I already said, if you want to win a prize, please use your real email address on Kahoot, and we promise that we won't use it for any reason except for to contact the winners. And if anybody is joining right now, the game pin will be visible at the bottom of the screen for the remainder of the games. All right, let's get to the fun part, prizes. So this month's prizes are really, really cool. So the top three winners will have their choice of these three prizes. So the first place winner will have the first choice, second place winner the second choice, and so on and so forth. And so our first prize is this limited edition Chime telescope Lego set, which is custom made by us. Chime being a radio telescope in Canada, being used by Canadian astronomers, and many of whom are at the University of Toronto. And a really cool little Lego set. The second prize is this 3D printed moon globe, which is a hit. It glows beautifully, and you tap it and it makes different colors, and it's really, really nice thing to put on your bedside table. And then our third prize is a Celestron travel scope with smartphone adapter. So this little telescope you can just carry around, and you can actually attach your cell phone to the eyepiece so you can take pictures through it with your cell phone. It's so cool. So those are the prizes for tonight, and I hope you're all ready to start playing because we're going to get into it. And make sure you answer those questions quickly, because whoever answers the quickest gets the most points, and whoever gets the most points has the greatest chance of winning one of these cool prizes. All right, let's get started. Okay, our first question is, where does the word galaxy come from? So this is a quiz about galaxies. And so where does it come from? Is it the Greek word for milk? Is it the Greek word for hair? Is it the Greek word for river? Or is it the Greek word for stars? So which of these does the word galaxy come from? The Greek word for milk, for hair, for river, or for stars? You've got just a few seconds left. Make sure you get those answers in. And the correct answer is that it is the Greek word for milk. So I think it's Galactia or Galaxa or something like that. Actually means milk. So, that's where Milky Way comes from, because the galaxy looked like milk splattered across the sky because it was all creamy and white, I suppose. So that's where the word galaxy comes from. Let's take a look at our scoreboard. In the lead right now, we have Amazing Urchin with Speedy Dog in a close second, only 1 point behind, goodness golly, and Melodic Iguana in third place. So it's a very tight run after this first question. So remember to get those answers in quickly. Our next question is, how many stars are in our own galaxy, the Milky Way? Named after milk. So are there approximately 100 million stars, approximately 200 billion stars, approximately 500,000 stars, or approximately 1 trillion stars? How many stars, approximately, are in our own galaxy, the Milky Way, pictured here in this beautiful image, stretching across the sky and looking absolutely lovely. So how many stars are in our own galaxy? And the correct answer, which most of you got, amazing job, is about 200 billion stars in our own galaxy. So our galaxy is this big disk of stars containing somewhere between 100 and 400 billion stars. It's not quite certain at this point. Most of it is estimates. And it's about 100,000 light years across, so this big disk of stars in space. So let's see how you all did on this question, and if the scoreboard has changed, and oh my gosh, it's changed dramatically. We now have Silly Llama in the lead still. Speedy Dog and Smiling Llama has moved up into third place. So excellent job, everyone. Moving on to our next question. What is the most common type of star in our galaxy? Is it red dwarfs, blue giants, red giants, or sun-like stars? So what is the most common type of star in our galaxy? Red dwarfs, blue giants, red giants, or sun-like stars? So what is the most common type of star in the Milky Way? You've got just about 3 seconds left. Get those answers in. And the correct answer is red dwarf stars, which the majority of you got. Excellent job. So the Milky Way is made up of many, many different types of stars, but the most common type of star is the lowest mass and coolest type, these red dwarf stars, which are the smallest types of stars you can find. There are actually very few blue giant stars, and red giant stars are stars that have actually reached the end of their life, and they don't stay in that phase for very long. And sun-like stars is about in the middle. There's quite a bit of those, but there are way more red dwarf stars. Let's take another look at our scoreboard. We have Smiling Llama still now in the lead, Silly Llama in second place, and Green Octopus in third place. So this is a llama-heavy scoreboard right now. Let's see how you all do on the next question, which is, which of these Greek philosophers was the first to guess that the Milky Way was made up of distant stars? Was it Aristotle, Plato, Democritus, or Socrates? So which of these Greek philosophers was the first to guess that the Milky Way was made up of distant stars? Aristotle, Plato, Democritus, or Socrates? We've got just about 7 seconds left. And your time is up. The correct answer, a pretty even spread across all of these. The correct answer is Democritus. He was a Greek philosopher, and he looked up at the Milky Way and was like, hey, maybe it's not a solid object or it's not some sort of cloud. Maybe it is actually individual stars that are very, 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 very far away. Looking once again at our scoreboard, we've got Silly Llama still in the lead. Amazing job. We have Mighty Falcon now in second place, and Green Octopus is still in third. The scoreboard is still pretty tight, though, so there's still a chance for everyone else to get up into the top 3. So let's go on to our next question. Why does the band of the Milky Way look dark in the middle? So you might have noticed that in all these pictures, there's that sort of dark band in the middle of the Milky Way. Is it because no stars exist in that region? Is it because there is a lot of dark matter in that region? Is it because stars in that region are not emitting light in the visible spectrum? Or is it because interstellar dust obscures our view? So for which of these reasons does the Milky Way look dark in its middle? So most of you got the correct answer. Excellent job. Which is that interstellar dust obscures our view. So in the spiral arms of our own galaxy, there's a lot of dust and gas that's that just exists amongst the stars, and that dust actually blocks our view of what would be beyond that. And if we were able to see through that dust and gas, then we would be able to see many, many more stars. And in fact, if you look in infrared light, instead of visible light, you can actually see a lot more stars because that light tends to penetrate dust and gas, whereas visible light does not. All right, let's see where we're at with our scoreboard. Silly Llama still maintaining their lead with Mighty Falcon in second place and Green Octopus in third. And Green Octopus has an answer streak of 5 in a row, so that's really, really great. That's commendable. Let's move on to our next question, which is, in which part of the Milky Way galaxy is our solar system located? So is it located in the core, so right in the center of our galaxy? Is it located in one of the spiral arms called the Orion Cygnus arm? Is it located in one of the spiral arms called the Perseus arm? Or is it located between two spiral arms? So in that sort of diagram there, would it be located right in the center of our galaxy, between two spiral arms, or in one of these two spiral arms, the Orion Cygnus or the Perseus arm? And most of you got the correct answer. It is, in fact, a spiral arm that we've labeled as the Orion Cygnus arm because it sort of follows where the constellations of Orion and Cygnus are from our view in the night sky. Okay, looking once again at our scoreboard, it hasn't changed all that much. Silly Llama's still in the lead with Mighty Falcon and Green Octopus close behind. But the night is still young. We still got many questions to go, so you still have a chance to get to the top of that scoreboard. All right, our next question is a true or false question. Is it possible to photograph the entire galaxy, the Milky Way? Oh, sorry. It is possible to photograph our entire galaxy, the Milky Way. True or false? I've got to learn to read better. Okay, so is it true or false that we can photograph our entire galaxy, the Milky Way? So can we take a picture of our entire galaxy? All right, we've got just a few seconds left, so get those answers in. And the correct answer, which most of you got, is false. We cannot actually take a picture of our entire galaxy because we are inside of it. And it would actually take a very, very long time to travel far enough outside of our galaxy to be able to actually take a picture of it. So you see all those nice images of other galaxies. We would never, or at least not in any of our lifetimes, be able to get a nice picture like that of our own galaxy, unfortunately. All right, let's look once again at that scoreboard. It has not changed much, so let's see if the next question mixes things up. So this next question is, which astronomer first ascertained that the Milky Way is disc-shaped? So we talked about the Milky Way galaxy being this disk of stars. So was it Edwin Hubble, Harlow Shapley, William Herschel, or Vera Rubin? So which of these astronomers first figured out that the Milky Way is disc-shaped? So you just got a few seconds left. Get those answers in. And I should say this is an image that astronomer made, a drawing of a diagram of what it should look like. So I'll show that once again. This little, not very big. This little image you see right here is that image that this astronomer took, or drew essentially, of what they thought the Milky Way looked like from the outside. And it was in fact the astronomer William Herschel, who worked very closely with his sister Carolyn Herschel, and they contributed probably pretty equally to this discovery that the Milky Way was disc-shaped as opposed to spherical, which would be a fair assumption as well. All right. Looking once again, oh my goodness, there's an upset where Smiling Llama has now moved into the lead and Silly Llama is in second place with Mighty Falcon in third. So there's a bit of an upset here where the scoreboard has changed. Let's see how it changes some more with this next question, which is a little bit of sci-fi trivia here. Why did the Vogons destroy the Earth in Douglas Adams' book, The Hitchhiker's Guide to the Galaxy? And that's not a spoiler because it happens very early in that book. But was it because they didn't like Earth poetry? Was it because it was an accident? Was it to make way for an intergalactic bypass? Or was it to turn it into a giant supercomputer? So for which reason did the Vogons destroy the Earth in The Hitchhiker's Guide to the Galaxy? So most of you got the correct answer, so I guess there are a few fans of this book out there. And it was indeed to make way for an intergalactic bypass. So the Vogons, they needed to get through there, so they just destroyed the Earth because it was in the way. which is a metaphor for humans doing things like that on the Earth. But I digress. All right, looking once again at our scoreboard, there is another upset with Silly Llama back in the lead, Green Octopus in second place, and Mighty Falcon in third. Let's see how y'all do on the next question, and we're about halfway through, so there's still lots of possibilities for upsets. So what type of object is at the center of most galaxies? Is it a supermassive black hole? Is it a large cluster of newly formed stars? Is it large amounts of gas and dust? Or is it a wormhole? So what type of object is at the center of most galaxies? A supermassive black hole, a large cluster of newly formed stars, large amounts of gas and dust, or a wormhole? And most of you got the correct answer. Maybe one or two of you have watched this trivia show before. It is, in fact, a supermassive black hole, and the supermassive black hole at the center of our galaxy is 4 million times the mass of our sun, which is very massive, very, very massive. Looking once again at our scoreboard, we have the llamas back in the lead, so we have Silly Llama in first and Smiling Llama in second, and Green Octopus and Mighty Falcon, you two are fighting for that other spot in the top three. All right, let's keep going. We've got another true or false question. So this question is, at least one very large galaxy does not have a detectable supermassive black hole at its center. Is this true or false? That at least one very large galaxy does not have a detectable supermassive black hole at its center. Is that true or false? It is true, which most of you got. Excellent job. And in fact, that galaxy is called Abell 2261, and there is no detectable supermassive black hole at its center. And that's very strange and very, very cool. But we think it might have been because two black holes might have merged, and that might have kicked them out of the center of the system, or maybe there's some other explanation. But we do not observe a black hole in the center of this galaxy, even though it's very, very large. It's about 10 times the mass of our own galaxy, the Milky Way. So, pretty neat. All right, looking once again at our scoreboard, we've got Smiling Llama back in the lead, Silly Llama in second, and Brave Pelican, you've made it to the top three. Excellent job. With Speedy Dog in a close fourth place. Going on to our next question. In which part of a spiral galaxy do new stars typically form? So in a beautiful spiral galaxy like the one we see here, where do the new stars typically form? Is it in the core? Is it in the spiral arms? Is it in the halo? Or is it equally throughout the entire galaxy? So where do new stars typically form in a spiral galaxy like this one? And most of you once again got the correct answer. Very good. It is in fact in the spiral arms. And in fact, you can sort of kind of see this in this image where you have those bright blue spots in the spiral arms. Those are in fact star-forming regions where you have new baby stars forming in these big clouds of dust and gas. And and that typically happens in the spiral arms of the galaxies. Whereas in the core, you tend to have older stars that accumulate there. Even though it's a high density of stars, there's not as much gas and dust to make new stars. Okay, looking once again at our scoreboard, it has once again changed a little bit. We've got Smiling Llama still in the lead, but Brave Pelican has moved to second place, and Silly Llama is in third now. So let's see how we do on this next question, which is, what do we call the closest galaxy to the Milky Way? So it is slowly appearing in an image here, but is it called the Pinwheel Galaxy, the Triangulum Galaxy, the Whirlpool Galaxy, or the Andromeda Galaxy? What do we call the closest large galaxy to the Milky Way? We've got about 10 seconds left. Get those answers in. There's an image of that galaxy, and almost all of you got the correct answer. Excellent job. It is indeed the Andromeda Galaxy. So that is a galaxy that is 2.5 million light years away, but is still the closest large galaxy to us. And it's part of what we call our local group of galaxies. So, looking once again at our scoreboard, nothing has changed. Interesting. Moving on. How long would it take to travel to the nearest large galaxy, that is Andromeda, with our current fastest spacecraft? Would it take about 4 billion years, about 500 million years, about 2.5 million years, or about 10,000 years? How long would it take to travel to the nearest large galaxy with our fastest spacecraft? That is the Andromeda Galaxy. All right, there's a pretty even spread here, and it looks like this was a tougher question. It would, in fact, take about 4 billion years with our current fastest spacecraft to get there. Now, if you could travel at the speed of light, it would take about 2.5 million years, because it's 2.5 million light years away, neglecting relativistic effects, of course. But our fastest spacecraft currently is the Parker Solar Probe, which is currently on its way to the sun to get some really cool close-up pictures of the corona of the sun and the surface of the sun. And its fastest speed will be about 690,000 kilometers per hour. However, even at that speed, it would still take 4 billion years to get to the Andromeda Galaxy, which is 2.5 million light years away. So we aren't going there anytime soon. Looking at our scoreboard, once again, we've got Smiling Llama in first place, Speedy Dog in second place, and Brave Pelican in third. For our next question, this is a similar question, but in fiction. So how long did it take passengers of the Ark Hyperion to reach the Andromeda Galaxy in the game Mass Effect Andromeda? Did it take 143 years, 634 years, 53,127 years, or 2.5 million years? So how long did it take the passengers of Ark Hyperion to reach Andromeda in the game Mass Effect Andromeda? Just got a few seconds left. Let's get in there. And I guess there's a few Mass Effect players in here. It did, in fact, take 634 years. So in Mass Effect Andromeda, they clearly have some sort of faster-than-light technology that we do not currently have in real life, though someday it would be really cool if we could travel at those speeds. Alrighty, looking once again at our scoreboard, we've got Speedy Dog in the lead now, Smiling Llama in second place, and Silly Llama in third. Still a very llama-heavy top three. Looking at the next question, which observatory has conducted the largest galaxy survey to date? So which of these observatories? Is it the Hubble Space Telescope, the Australian Astronomical Observatory, the Apache Point Observatory, or the W.M. Keck Observatory? So which of these has conducted the largest galaxy survey to date? Get those answers in. Oh, everyone answered before the time was up. That's amazing. So, in fact, very few of you got this answer. It is the Apache Point Observatory, which has been conducting the SDSS survey, which stands for Sloan Digital Sky Survey, with the SDSS telescope. And this survey has so far mapped out, characterized millions of galaxies in our visible universe. So it's doing a really good job. Looking at our scoreboard once again, I have a feeling this might have... Oh, it didn't change anything. Goodness golly. Okay. Well, we still have Speedy Dog in the lead with Smiling Llama and Silly Llama in second and third place. Our next question is, what are the names of the 3 basic types of categories that astronomers use to classify galaxies? Is it red, blue, and yellow? Is it oblong, spherical, and peculiar? Is it barred, lenticular, and regular? Or is it spiral, elliptical, and irregular? So what are these, the basic three categories that we use to classify galaxies? And most of you got it after that last very hard question. I'm very glad to see you all bounce back. It is indeed spiral, elliptical, and irregular. So spiral galaxies are those ones with the nice spiral arms that look sort of like our own galaxy, the Milky Way or Andromeda. Ellipticals look sort of like spherical egg shapes. And irregular galaxies are just kind of weird looking. They have weird, strange shapes that can be classified into those other two categories. Once again, looking at our scoreboard, nothing has changed again. So let's see how it looks after the next question. So we're nearing the end here, just a few questions left. What type of galaxy is typically the largest? Is it spiral, irregular, lenticular, or elliptical? So what of these four types of galaxies is typically the largest type of galaxy? Is it spiral galaxies, irregular galaxies, lenticular galaxies, or elliptical galaxies? Give you a few more seconds to answer this one. And many of you got the correct answer. It is, in fact, elliptical galaxies. So those weird egg-shaped or football-shaped or spherical-shaped, whatever you want to call them, types of galaxies that are basically just big spheres of stars. They are typically much larger than spiral galaxies. And if you can see from this image, this is many, many galaxies. And this big one in the middle is a very large elliptical galaxy, and these smaller ones tend to be the more spiral-shaped ones that you can see around here. All right, on to the scoreboard. Let's take another look. Still hasn't changed. All right, let's move on to our before last question. So irregular galaxies are usually formed by the merger between two galaxies. Is this true or false? Is it true that irregular galaxies are usually formed by the merger between two galaxies, or is it false? So, get those answers in. You got about 10 seconds left. Try to go ahead and fast so maybe we can unseat those top three. All right, it looks like most of you got the correct answer, which is in fact true. So when you see those strange looking galaxies that have these weird shapes, which we call irregular galaxies, they are formed usually by two galaxies crashing into each other or interacting gravitationally with each other. So, for example, in several billion years, the Andromeda galaxy will actually merge with the Milky Way, and then instead of having two spiral galaxies, we'll have a big irregular galaxy in the end. All right, our scoreboard has changed a little bit. Smiling Llama's back in the lead with Speedy Dog, and then Silly Llama close behind. Let's look at our final question of the night, which is a Marvel question. Which galaxy was the Kree Empire from the Marvel Cinematic Universe supposed to have come from? So was it the Andromeda Galaxy, the Milky Way Galaxy, the Large Magellanic Cloud, or the Shi'ar Galaxy? So which of these galaxies was the Kree Empire from the Marvel Cinematic Universe supposed to have come from? And also from the Marvel comic books, I should say. And the correct answer is the Large Magellanic Cloud. Oh, I got you with a lot of those. So the Shi'ar Galaxy was actually another race that is in the Marvel Cinematic Universe that it came from, and it's actually a fictional galaxy. But the Kree were supposed to have come from the Large Magellanic Cloud, which is actually a dwarf galaxy that is in orbit around our own Milky Way galaxy. So it's like this little mini galaxy that's going around our big Milky Way galaxy. All right, we're at the point where we can figure out who finally won this thing. So in third place, we have Silly Llama. Oh my goodness. In second place, we have Speedy Dog, and who is it in first place but, drum roll please, Smiling Llama. So excellent job to our top 3. We'll be in contact with you via email, as long as you put your correct email in the Kahoot, and we will get in touch with you with how we shall distribute those prizes to you. And I hope that everyone had a lot of fun playing. Good job to everyone who played. And we're really excited to have you here every month and look forward to seeing you again next month. So good night, everyone.